Hello, I'm Necmettin. Welcome to my Omnet lab video, which is the third one. Uh, in this video, I'm going to explain the Inet step 10A to step 10C. We are going to explain the wireless networks between the seven end devices, and we're gonna also explain the AODV protocol, which is the ad hoc on demand distance vector, which we are going to use this protocol for the creating uh, routes between the end devices dynamically. And let's start our presentation with the our configurator D. Our schema will be like this with the seven different end devices, and we're gonna also use the AODV for each host devices as well. And when we get our 10A, let's start to explain 10 from the 10A. We connected to our network is configurator D, which I just mentioned here, and we are going to use the config file, which is the step 10A XML on here, like this. Uh, we can see the each host and address will be the automatically configured from the XML file. It statically configures the addresses and the net masks. And there is one specific a parameter on here which is called auto route metric equals error rate. Then that means that every device will try to create routes between the another end devices hosts, and you'll see the circles within the each end devices, and if there is a device outside of the circle, there will be no routes uh, for this uh, within these two devices. And you can say that error rate will be infinite outside of the circle. That means that you can't create routes between these devices. And let's see our 10A again. We're gonna use the bit rate, which is 54 megabit per second, and the radio transmitter power will be the 1 milliwatt. And our visualizer on here, the routing, we will able to see display the routing tables. We can see the display. We can see routing tables, label format, and line shift. These two statements are about to make simplification between the routing tables and the routes, and the destination filter with the asterisk. That means that we will able to see all of the routes between the uh, each devices, like 1 to let me see it again, 1 to 4, maybe 4 to 6, all of the rows. And on display communication ranges, also true. And let's start our 10A. By the way, we have no package sending or package receiving on this configuration because we didn't define any package sending or receiving. Uh, if we start this uh, simulation, we can see that there is no package sending and package receiving. It just created routes between the host devices. Let me explain this like this, and let me start this as well. Uh, Maybe after the 50 seconds, I maybe terminate the simulation. Yes, let me explain this. Each end device will have the circle, which is the range of the signal. And if there is one or more devices inside of this circle, the host will try to create routes between these devices as well. But if there is a device which is outside of the of this circle. So error rate will be infinite, and there will be no roots and routing tables. So uh, example, you can see the host one on here, and inside of this circle, host one signal distance. There is also host 4, so you can see that the route will be created between host 1 and the host 4, and the host 4's distance is like this, and we can see that this circle will include the host 6 as well, and so the protocol will create host 4 to host 6. Between the host 4 and host 6 there will be a route, and let me terminate this. And let's examine our results on the 10A. So we can see the browse data. Let's say packet drop, maybe drop count. As it can be seen here, you can see there is no package drop or package return, package sending, because we haven't configured uh, any package sending, or we have no routes, I mean no destinations, and no feedbacks or no requests. So we are unable to see any data from this uh, simulation step 10A. Let's save this, and let's get our 10B, which is, you can clearly see that it will inherit from the step 10A as well, but this time we have also another statement called add static routes, which is false. That means that we ignored the our XML file, so we are unable to create uh, no no routes between the devices. Let me see this again. Sorry for that. I have to check the 10A again, because there may be some issues. So for that, we are going to use the AODV on the step C. We created on the 10A, we created routing tables and the routes, which is static, which comes from the XML file, but on the step 10B we ignored the XML file, and we add static routes. I mean, we won't ignore the XML file, but we won't able to create static routes between the end devices, which we specified the value false. So when we start our simulation 10B, 10B, you can clearly see that there won't be any routes between the hosts. So you can see the distances, you can see the circles between within the devices, but there is no routes. Let me start this simulation, but you can see that they are sending some kind of signals, maybe. I'm not sure for that. Let me see this. Yeah, counter timer with, they are trying to use the AODV as well again, but we ignored the error rate metric for the I assume creating static routes between the devices, but you can clearly see that we have no routes. So we also won't have package sending and the package receiving as well, because we have it configured it in our ini file as well, to step 10a to 10a to step 10b. Let me finish this, and let's see our 10b. Packet, let me search the packet drop again. Packet drop count. You will see that there is no data on this chart as well, because there is no packet sending or package receiving. Maybe you are curious for the examining the see the package receive package sent as well. Send count, yes, on here. Uh, so there is no package sending as well, because we haven't configured it in our ini file on the 10b. Let's save them. And so let's start our 10c on here, which this time we configured application, which is the ping application. Host 1 will send a ping to host 7, but this time we are going to use AODV route, AODV protocol for creating routes between the end devices dynamically, and not statically but dynamically. You can remember that on the previous lab we used DHCP server for assigning IP addresses for the unconfigured host devices, and we were giving the IP addresses to that devices. This time we're gonna execute some similar process for the routing tables, which is dynamically as well. There won't be static routing, which comes from the XML file, and we also have a package sending and package receiving with help of the ping application as well. And this configuration also inherits from the step 10b as well, and it will also use the configurator D, which is on here, because it inherits also the properties of the 10a as well. And let's start our 10c. Yeah, this time I'm gonna wait for the creation of the all of the routes between the devices. Yes, you can see we have our schema, we have our devices and the signal ranges, and I'm gonna execute the simulation. Yeah, you can see that they are sending signals which are related with the AODV protocol for creating routes between the end devices, and we can say that if there is a route which is not used in a while, that route will be faded. It will be destroyed automatically. I can explain like this: like host 1 will send a package to host 7, and it will use this route between the host 1, host 4, host 6, host 3, host 5, and host 7. But host 2 won't be used, so the routes between the within the host 2 will be destroyed. Yeah, I'm still waiting for the creation of the all of the routes. Yeah, we can clearly see that all of the routes are created. I came back with the step 10C. There was a unforeseen issue about the ChatGPT, so I'm gonna execute the step 10C simulation again with the shorter result. From now on, we've finished our routing tables, and we have routes within the all devices. And so I'm going to copy the results till the maybe this event. This I hope this time there won't be any errors, and so I'm going to share it, and we still have errors. Yeah, you can see the routing table configuration between the host 5 and host 7 from my results, which is here. This is the row about the routing table between the host 5 and the host 7. Uh, we can uh, we can process our data with the ChatGPT, our results like this, and that was the purpose of this lab 3 assignment. So when we see our simulation again, I'm going to terminate this on here, and I'm going to examine the charts again. And now we are able to see our results from the 10C, and I just discovered that I assume I accidentally showed the vector results of the 10A and the 10B, and I was supposed to show the results in the scalar form. So I'm going to show you the scalar results as well. But firstly, I'm gonna examine the results for the 10C. And let's open our scalar results. Let's firstly, I wanna see the package drop, and I assume that there is no package drops because they are sending. There is no package drops. No. Yes, just like I imagined, there won't be package drops. And so let's start our Scala result again, but this time I want to examine the package sending. Package send count. And let's see our package send. And so you can see that our host 1 and the least one is the host 7. Host 1 sent data to host 7, but let me see this again. But this time host we also use the most device that was used is also host 4, which is here, because host 1 directly sends data to host 4. You can see like that, and host 2 and the host 3 they are acting like bridges, but mostly you can consider that host 6 and the host 3 are the most ones which are used. But you can see in this scenario they are equal, and the host 5 and the host 7 is the least sender, package sender. Here's the results. You can see And let me show you the other results as well, which is scalar for the 10A. I also want to show you the packet drop. There is no packet drop as well. So also I want to see the packet send. So you can see that there won't be packet sent because we aren't configured packet sending and packet receiving in the 10A and the 10B. And let's open our 10B again. Packet drop. Just like you mentioned. And the packet sent. And there is no packet sending as well because just like I said previously, we didn't configure the packet sending and receiving in the 10A and the 10B, only in the 10C. And the most sender is host 1, and the less receive senders are the host 7 and the host 5, which they are on here, because it was like sending and waiting for the response stuff, I assume. But in this scenario, you can see this results like this, because you can assume that the sender will send the most data like this. The adjacent device will also will be affected from it. These middle ones are acting like the bridge, and the receivers are the less senders, because we can think about it. They're just receivers, and that's it. And here's the end of the video. Thanks for watching.